Alright, so we are going to be going over 4.5, and this is going to take 2 videos, otherwise it's going to be long as all get out. It's a lot of sections, but 4.5 is the last section of our unit in which we've got a test hopefully scheduled. We're going to try and keep it at April 22nd. So make sure you're keeping up with things. 4.5 is actually solving exponential and logarithmic equations. Okay, so we're actually going to find some. There's going to be a section in here that you could technically, you get an answer decimal wise that's going to be kind of crazy, but we're going to show you how to answer these without using a calculator and get an exact answers. Okay, first one is solving exponential equations. So if you look here, we have an exponential equation. Pull it up a little bit because the exponents are small. Okay, so I have base 5 to the exponent of 3x minus 1 is equal to 125. So I have an equal sign, which gives me my equation, and it's in exponential form because I have a variable in the exponent. So our first thing for us to try to do is that we want to see if I can make things in the same base. Okay, now this is base 5. Okay, so that's my base. So the whole goal is, can I change 125 into base 5? And I can as 5 cubed. Okay? So when I do that, 5 to the 3x minus 1 is equal to 5 cubed. Now when I have the same base, if you think about it, if I told you 3 to the 2x is equal to 3 to the 10, how would you figure out what would you have to put in for x to make these two equal? Well, I'd have to make that a 5, right? Okay, because then the whole thing's equal and the bases are the same. So since I have the bases are the same, all I have to do is take the exponents and set them equal to each other, assuming the bases are the same. Once you get them the same, then I can solve this. I have 3x is equal to 4, or x is equal to 4/3. And that is going to be the answer. Whoops, sorry about that. That is going to be the answer of this problem. Okay, so let's look here. Well, I do have this. Are those the same base? Well, I know 4 and 8, I can make those into base 2. Okay, because 8 is 2 cubed and 4 is 2 squared, right? Well, if I make this 2 cubed to the x and 1 over 2 squared, well, they're still not technically the same base, but what happens if I move this 2 up to the top? Wouldn't that become 2 to the negative 2 is equal to 2 to the 3x? And how do I get 3x? Well, I have to multiply exponents, right? Now we have the same base. Base 2. So now I can take the exponents and make them equal to each other, and I get negative 2/3. Alright, so now we look at this last one on this little section. And again, we have the 8 and the 4 again. We already know I can change those into base 2. So the 8 is going to be 2 cubed to the x plus 3 is equal to 2 squared to the 5 minus 2x. Now, if I remember my exponent rules mean I can multiply those together, and they'll have the same base. So wouldn't this be 3x plus 9 is equal to 10 minus 4x? Okay. Now, I can solve for x. Move the 4 over, move the 9 over, divide by 7, x is 1/7, answer. Okay, so easy way if you can get things into the same base. Right? Now, what happens when you can't get them into the same base? Well, what do I mean by that? Well, here's base 2. Okay, well, 7 can't be written as base 2 because I know 2 cubed is 8. 2 squared is 4, which means the number that's got to go here has got to be between 2 and 3. Okay, well, to get that number you'd have to use a calculator. You're not supposed to use calculators. Okay, we were going to let you, to get that exact well, I should take this. We're going to show you how to find the exact answer. And the exact answer will not have a decimal. Okay? So, how are we going to do that? Well, we're going to take the 2x is equal to 7, and what we're going to do is we're going to log both sides. And I can either use common log or natural log. It doesn't matter. Okay? So I can log this side and I can log this side. Okay? Now, what we're going to do next is we're going to use our log properties. So remember what we do with exponents. The exponents here go to here. And this is why we use the logarithm, so that I can bring this exponent out to the front. Okay? Now, I want to solve for x, right? So this is x times log base, or common log of 2, which is actually a number, it's a decimal. But what I want to do is I want to get rid of this. I'm going to move to the other side. Well, how am I going to do it? We're going to divide. So x is going to be the log of 7 over the log of 2. Okay? Now this is what we call exact. Okay? If you were to put the decimal in, which would be an estimate answer, you could in your calculator put log 7 divided by log 2, and you would get 2.8074. Now what's interesting is log 7 divided by log 2 is equal to the natural log of 7 over the natural log of 2. They would both give you that number. That's why when we go over here, we said log of both sides. You can also natural log both sides. I tend to use natural log a lot of times just because it's an easier number to write. Okay? Alright, so let's kind of continue that strategy. If you notice here, this is base 3. Well, that's not base 3. Okay? And so here's my exponent. So I need to get that exponent out the front. So this time I'm going to use natural log. So we're going to go natural log of 3 to the negative 0.02x is equal to the natural log of 0.07. Okay? So what we're going to do is bring that exponent in the front. Okay, so it'll be negative 0.02x, okay, times the natural log of 3 is equal to the natural log of 0.07. Okay. Alright, so now we're going to do like we did before. We're going to divide both sides by natural log of 2, or natural log of 3, sorry, that's a 3 there. Okay, so we go natural log of 3. Okay, so now we have negative 0.02x is equal to the natural log of 0.07 over the natural log of 3. And I still have to get x by itself, which means I'm going to divide both sides by negative 0.02. And we're going to get an exact value of negative natural log of 0.07 over 0.02 natural log of 3. Which, we're not going to give you all these decimals on any kind of test or anything, but that would be an exact answer. Okay? If you plug this into a calculator, you would get approximately 121.0281. Okay? But, again, we're not going to be using that much. Okay? Alright, so, what if we have a little bit more stuff in here? Okay? Well, we're going to follow some of the same ideas that we've been dealing with. Okay? So, we're going to subtract the 4 and just get 3e to the 2x is equal to 7. Okay? And then we're going to divide by 3. And we're going to get the exponent piece by itself. E to the 2x is equal to 7/3. Okay? Now, here's where picking the type of log you're going to use is important, because this is base E, right? And the type of logs that go into base E is going to be natural logs. So here we're going to do a natural log to both sides. And it comes in handy because what happens is this. We're going to get the natural log of E to the 2x is equal to the natural log of 7/3. Okay? Now, why this is important is because this is base E, right? And we have a special rule that if this is E and that's E, then this whole thing equals the exponent. Okay? So, now I can solve for x. Makes it a lot faster. I can divide both sides by 2. Now, what you're normally going to see, this answer, which is exact, is usually going to look like this. Bring the fraction out in the front, the 2 out in front as a half, and that's usually the answer you're going to see. Okay? The approximate answer to that, if you were to put it in the calculator, is this. Okay? Alright, so then we got one more. Okay? Now, this one is the trickiest of the bunch, okay, because you have two bases on both sides. Okay? And so if I log both sides, and the reason you log both sides is so that I can bring this exponent out front. So we have 3x minus 2 times the natural log of 2 is equal to 2x plus 1 times the natural log of 3. Notice what I did. Exponents came out front, and then I did natural log of 2 and natural log of 3. And you can do log if you want. Common log is fine. You can technically, as long as it has the same base, you can use any log you want. Okay. Now it doesn't really matter because they both have different bases. Okay. So, and the reason we use common logs and natural logs most of the time is because that's what's in every calculator. Okay. All right. So here's where it gets a little tricky. Okay. Now, those of you who had logs before, pre-cal kids, you've seen this before. We're going to distribute the natural log of 2 to both of these. So we have 3x natural log of 2 minus 2 natural log of 2. And the same thing here, 2x natural log of 3 plus natural log of 3, which is 1 times that. Okay? So we have this. Okay? Now what we're going to do is we're going to get the things that have x's on the same side. Okay, things that don't have the x on the other side. So we're going to bring this one this way, and we're going to take this one, move it to the right. So I'm going to get 3x natural log of 2 minus 2x natural log of 3 is equal to 2 natural log of 2 plus natural log of 3. Okay? Now, how do I solve for x? Well, notice this has an x and this is an x, but they are not like terms. So I cannot add them together or subtract them. But I can factor out the x. So I have 3 natural log of 2 minus 2 natural log of 3. And here's where doing the exact is the best part. We're going to divide everything by this parentheses. And so we get x is equal to 2 natural log of 2 plus natural log of 3 all over 3 natural log of 2 minus 2 natural log of 3. And that is my exact answer. Okay? Now, this answer, if you want to put this in the calculator and see what it does, you can. It's kind of tricky. You would actually have to type it in this way. Divide it by this one. And really on a, like your phone calculator, it is a pain in the butt. Okay, on a graphic calculator, not so hard. Okay? You can also do 2 times the natural log of 2, write that decimal down, plus natural log of 3, write that decimal down, write this decimal down, write that decimal down, add those decimals, subtract those decimals, and divide. It's up to you. But again, we're not using calculators, so you don't have to do that part. Alright, then this last one. Okay? Kind of refresher on some factoring skills for you. Okay? Because if you remember, this is what we call quadratic form because look at the exponents. This one is half of this one, which means it can factor. Okay? So, since it can factor, I'm going to do e to the x, e to the x. Okay, that was our rule. And then what multiplies to 12 that adds up to negative 8? Well, that would be negative 6, negative 2. Okay, now, what are we going to do with that? Well, we're going to set this equal to 0. And we're going to set this one equal to 0. And we're going to solve for x. Okay, so I'm going to show you the first one. Okay, we're going to set this x, e to x is equal to 6. We're going to natural log both sides. And the reason we natural log both sides is because, remember, that's base e. That gives me x is equal to the natural log of 6. Okay. And then you do the same thing here. Do the same thing, natural log both sides, and x is equal to the natural log of 2, which are both decimals. Okay. And which is fine. Okay. But we're not asking you for the decimals. And these are exact answers. Okay. So that is part 1 of 4.1.